All right, so today I'm going to be talking about the examples that we have for lesson 7-1 in our textbook over equations and inequalities. Now, these first two examples that we're going to talk about have to do with equations, and that's probably what you guys are all familiar with. An equation is just some kind of math problem, something equals something. Now, we're going to be kicking it up a bit and doing some algebra, and by that I mean we're going to have what's called a variable inside our equation. And you see that word right here in our explanation. A variable, for those of you who don't know what it means, is basically what you always hear in like algebra or math class where they say they have like x or y equals something, or maybe even a, b, or c. It's always the letters. So make a little note to yourself somewhere on the side that whenever you see the word variables, it just means it's a letter. And in math, a variable means a letter that has some certain value. It could be any number you want it to be. And because it could be any number you want it to be, it could vary, in other words, which is why we have the word variable. Now, in order to do the work today, we have to understand what's going on. Today we're going to be talking about, it says to determine solutions of a two-step equation. And many of you guys are probably wondering what that means. And I agree with you. It's kind of hard to explain until you actually just start doing it. But we can break down some of it. We know we're going to have what's called a two-step equation. That's a math problem that requires you to do two things, between add, subtract, multiply, divide, any combination of those things. Determine solutions just means we're going to try to figure out what numbers we can put in there to make these equations true. And let's just delve into the first example, and I think it'll become a little clearer what we're talking about. So I'm going to go ahead and scroll down to example number 1 on my page here. So let me go ahead and just grab that. I'm going to go ahead and clear my screen so you have a nice fresh page to look at. Let me zoom in a bit more. And I understand that we already have a chart here with all kinds of math work done in it, and what I'm going to do to go ahead and make it a little easier for us to work together is I'm going to go ahead and just kind of blank out all the stuff that's in this box and the wording that's beneath it for this example. And to make it a little easier to write on, I'm going to go ahead and just fill in this box, color it white, and then now we have this nice blank looking chart. So let's go ahead and talk about what we have here in example 1. It says determine if the numbers 4, 5, or 6 is the solution of the equation 2c plus 5 equals 17. So they gave us an equation, and as the title said before, it is a two-step. There's two math operations going on. And they want us to figure out which one of these numbers, 4, 5, or 6, when we plug in for the letter c, will equal 17. So we have a couple of steps here, and we have the values here in the chart below. So I'm going to go ahead and show you how to do this on your paper. First rule says try each value. A general good rule in algebra is whenever you're doing any kind of math work is to always write your equation first. Our equation we see is over here on the side. 2c plus 5 equals 17. The question mark's on top because they want us to figure out what number we're looking for. So I'll go ahead and just write 2c plus 5 equals 17, exactly the way they give it to us. Now the first value they give us that they want us to use for c is the number 4. So instead of wherever I see a letter c, I'm going to go ahead and plug in a number 4. And I'll show that it was replaced or substituted by putting it in parentheses. Then I go ahead and continue to write the rest of the equation. Now I look at my equation and try to analyze it. I see that I have 2 next to the number 4 in parentheses. And for those of you who may be unfamiliar with this, a number next to another number in parentheses means multiplication's happening. So we have multiplication right here, and we have addition right here. Well, if I remember the rules of the orders of operation, which is PEMDAS, I know that multiplication comes before addition, so I'll go ahead and work this out. 2 times 4 is 8. Now I have 8 plus 5, we're hoping equals 17. And if I do my addition now, 8 plus 5 equals 13. 13, however, is not equal to 17. So the number 4 up here is not a solution. So I'll go ahead and just kind of exit out. It's no good for us. It doesn't help us. So now I'm going to repeat the same process with the next 2. I'll go ahead and clear my screen out, or actually I'll just erase what I wrote. And then I'll work on number 5. Let's change the color up a bit. So now I begin by writing the equation again, which is going to be 2c plus 5 equals 17. The value I'm going to plug in now is going to be 5. So 2 times 5 plus 5, we're checking to see if it equals 17. Following the orders of operation, 2 times 5 comes first, which is 10. 10 plus 5 equals 17. When we add, 10 plus 5 is actually 15 and not equal to 17. So since these are not equal, number 5, or the value 5, is not a solution either to our equation over here. So now all I have left with is the number 6. It's possible 6 may also not work. That is possible mathematically, which is why you always have to check and do your work. So let me go ahead and erase what I just wrote now. And I'll go ahead and change the color a bit to purple. And let's go ahead and do this last value here. Start off always, write your equation just as it's given to you. I'm going to substitute the number 6 for the variable c. Using the orders operation, I know that multiplication comes before addition. So 2 times 6 is 12 plus 5, we're hoping equals 17. 12 plus 5 does indeed equal 17. So since this does equal this, according to this symbol, then this also must be a solution. So 6 is the solution, or the answer, what c has to be to make this equation true. And when we kind of go back and clear everything up that I've written and made here, we have, because 2 times 6 plus 5 equals 17 is a true sentence, the solution of the equation 2c plus 5 equals 17 is 6. So because these two things ended up being true, then we know that this right here is our answer. We're going to go ahead now and try the next example. So let's go ahead and just scroll on down to the bottom of the page here, or I guess for you guys, just look down. And we have the same type of thing here. It looks a little more busy because we have all this decimal stuff going on, but I'm going to help make that a little clear for you. So just as I did before, I'm going to go ahead and just cover up pretty much everything on this page so we have a nice workspace to use. I would suggest you guys probably be doing all this work on a separate sheet of paper because you don't really have enough room on the side. Now let me go ahead and fill this white, adjust it so everything's covered up nice and neat for the most part, and then get back to work. So now we have a new expression. We actually have a new set of directions. The directions now say determine if 2.4, 2.7, or 3.6 is the solution of the equation d over 3 minus 1.4 equals negative 0.5 or negative half. Now the rules are exactly the same as before. So just like I explained in the last example, we always start off by writing the equation. So write your equation. Now, they give us a value to substitute for our variable. Our value is 2.4. Our variable is the letter D. We see that right here. So wherever I see the letter D, I will plug in a 2.4. So I have 2.4 over 3 minus 1.4 equals negative 0.5. So just as expected, as our last example was, and as it says in the title, this is also a two-step equation. I've identified that I have subtraction right here, but here I just see a fraction. In case you didn't know, fraction bars are the same thing as a division symbol. So I have division and I have subtraction. Using PEMDAS, or the order of operations, I will have to divide first. Some of you may be concerned about dividing with decimals, so here's a little trick I would do with these. Ignore the decimal point. Think of this as 24. What's 24 divided by 3? The number 8. I have one decimal right before my last number, so I'll also have a decimal before my number here. So now I have 0.8 minus 1.4 equal to negative 0.5. Now we got to do some thinking. This is going to be some integer work. 0.8 is pretty much equal to 80 cents. So I have 80 cents, minus means I'm spending $1.40, or I'm going to buy something that costs $1.40. Obviously I don't have enough, so how much would I need? Well, from 80 cents to $1.40, 8, 9, 10, 11, 12, 13, 14, that's going to be, I need 60 cents. Well, needing 60 cents and needing 50 cents, as we see above here, are not the same thing. So 0.6 and 0.5 not equal, so 2.4 is not one of our solutions. Let's go ahead and try the next example. I'll begin by erasing what I just did and repeating the process all over again. If you've already grasped the process, I suggest you go ahead and work ahead of me and then compare your answers at the end to see if we get the same thing. I have 2.7 divided by 3. I'm going to go ahead and just substitute automatically now my my value for the variable just to save some time equals negative 0.5. I'm going to consider this again, just ignore the decimal and can think of this as a 27. 27 divided by 3 is going to be 9. I have one number after the decimal point, so I have to have the same thing here. Now I have 90 cents minus $1.40. Is that going to be equal to needing or owing 50 cents? I have 90 cents. I want to buy something that costs $1.40. I know I'm going to also need 60 cents. That cannot be right. 9, 10, 11, 12, 13, 14. Oh, 50 cents. There we go. So Sometimes when you do math a little too fast in your head, you tend to make a mistake. Now, I have a true statement. Negative 0.5 is equal to negative 0.5. It doesn't matter if I have a 0 in front of my decimal point or not. I'll make that 5 a little clearer there. So this is a true statement. Therefore, 2.7 is also a solution. Well, normally you might think I'm done now, but because we're dealing with equations and we have one more answer to check, it's always good to use all your choices to make sure or verify that you indeed have the one and only true solution. So let's go ahead and repeat the process one last time. I have 3.6 divided by 3 minus 1.4 to check to see what equals negative 0.5. 36 divided by 3 is 12. I have one decimal between the two numbers, so I have the same thing here, minus 1.4, and I can already tell that I'm not going to have a negative. I'm going to have a negative number, but it's not going to be the same. $1.20. You want to buy something that costs $1.40. You're still going to need 20 cents. That is not equal to needing 50 cents. So we just verified that 3.6 indeed does not work. And when you review what the book says, we have the same thing here. 2.7 ends up being the only legitimate answer. So now that you reviewed these first two examples, go ahead now and scroll to the bottom of the page, or move to the bottom of the page, and work on A and B. I will give you some advice. On this problem for A, this is exactly like example 1, and B, as you probably guessed by now, is exactly like example 2. You can use the same kind of methodology. You need to remember your rules for integers when you're dealing with this right here, when you're adding negatives, so go back to chapter 1 if you need to review that. You will need to also have these problems solved by tomorrow because you can be potentially asked these two questions on a quiz. Good luck.